Good evening and welcome back to a new year of Azure Thursday. This is the first one of the new year. We didn't leave COVID yet, so we're still doing this from our home offices, but we're excited to be
Unfortunately.
here. Excited to be here again, and let's have a great evening.
Yeah,
Roland, how have you been?
I've been well, thank you. I've enjoyed some very nice Christmas holiday. It was time for some relaxation at the end of the year, but we're now fresh and happy to start with 2022. And how were your holidays? Oh,
My holidays were great. Didn't do too much outside of the house, but we still managed to get a great Christmas and New Year's in. So I had a great time. And of course, putting your feet up for a week is always amazing.
yeah, that's always a very good way to end the year, and especially this COVID riddled year with all these strange measures that we're dealing now today. Still, unfortunately, but today we are ready for a new Azure Thursday.
We are. Shall we
Shall
bring
uh,
Frank
shall
in?
we shall we get our guest here? I think Frank is ready and can join us. So let's
Yep.
put him in the stream.
Here he comes.
Hi, Frank.
Hey,
Hi,
good
how are
evening,
you?
guys.
Good
I'm
evening.
all right. Yeah.
Super. Excited for your talk, for your session here with us.
Yes, I see only the two of you, but I hope that many more will be out there watching us. So
Yeah,
let's see.
unfortunately, this was what this edition was intended to be an in-person event at the offices where you work, right? So you work at Schubert Phyllis.
Yeah, we have a big room. Some of our audience may have been there during the Tweakers events. Like we can host easily a couple of hundred people in our space, and yeah, we would have loved to be on stage now, but
Well, we'll make
situations
the
have
best of
changed.
it.
But I am still quite excited to share a little bit with what I've been up to and why I get excited for, amongst other things, some of the stuff Azure has to offer, being relatively new to Azure. So yeah.
Oh, very good. It would be very good to get your perspective on things. But before you can start, for me, the COVID measures also mean I don't have to travel as much, so I have some extra time, and I try to use that time to learn new things. What is the coolest thing you have learned last year?
The coolest thing I've learned last year. I think I had the pleasure last year of really diving into both AWS and Azure. So I joined Schubert maybe 1.5 years ago, and before that I didn't really have had any experience with a cloud at all. And I got to learn a little bit about AWS and about Azure. I got to use them both, got to compare them a little bit, and some things are still a mystery for me, but other things I was pleasantly surprised by how easily I could pick them up and grasp them, and I could already see how it would have made my life a couple of years ago so much easier having the tools at my disposal. So yeah.
Very cool. Thank you. And I think you can just take it away. We're very excited to hear your story on data and Azure Synops Analytics. And I'm now going to spoil.
Yeah. We'll just stop now. Okay, I'll take it over.
I'll take
from
a time
here.
out.
No
Just
worries.
take it away.
Yeah. Thank you, Roland. All right, let me share my screen. Yes, the title of my talk, getting rid of silos, embracing MLOps, democratize data. It all sounds very catchy, but how do you actually do it? Well, this is a lousy title. I basically want to talk to you guys about some cool piece of tech that I got excited about, and I think it can maybe solve some of the problems behind these slogans that people keep shouting at us. Before I want to dive into this, I want to give a brief overview of who I am and where I am at the moment in my journey. I started life as a physicist. So on the very top left, you see Bart Simpson. I could walk into my lab every day wearing shorts and flip-flops. I was doing stuff with lasers in a lab, resulting in me getting a PhD in physics in Leiden. And then I started to think seriously about a more grown-up job. And then at some form or the other, I ended up in finance. I became a risk management consultant, a quant, if that resonates with you. So all of a sudden, I was working at the Zuidas in Amsterdam. I needed to wear suits. So I went from wearing shorts and flip-flops to suits. And I basically made models for different banks, mainly for mortgage portfolios. And I did that for about 3 years with a bunch of cool colleagues. I enjoyed it immensely. What I didn't like that much was that we all built models from a regulatory point of view, so where there were lots of hoops we needed to jump through, and it got a bit tiring. So I thought it's time for a change. And then I, by accident, came in contact with Schubert Phillips, the company I now work for, and I am now this sort of mad data scientist that you see on the top right. I get to wear whatever the F I want. And I get to do some pretty cool things, of which I would like to share a little bit with you today. So I would like to highlight and use my time with the banking industry as sort of a scaffold for this talk. And I would like to show you a little bit what environment I was working in, what I was part of. So I was part of the modeling department, the quants department, and thinking that we are the center of the world, I've drawn myself in the middle. And we had one job. We needed to create good models. Well, obviously, for good models, we need data. We need data to build our models on. So typically, I went to the historical data team and said to them, hey, can you give me some data? Because their job is to create and deliver quality data sets. And then they came back to me with like, yeah, okay, but can you specify then what data fields do you need? And I was like, well, I don't know yet. Just give me all of them. You might have heard this, right? These annoying data scientists that want access to all data and then figure out themselves what to use. Well, we went back and forth quite a bit between me going to them, they coming to me. Well, actually, for each request I did, they also needed to look into the source system. So they needed to go to the production IT systems. Hence, there's a dashed line all the way over to IT run to actually see what kind of data we have available in the systems. So their life was also not that easy. Then on the very right, I already mentioned that IT run. Believe it or not, once I've made a model, I needed to write a model document. I needed to write down with formulas what my model looks like, such that the IT run department can copy those formulas and implement them into their systems. So we're not shifting like packages or deployed models. No, on a piece of paper, they needed to reproduce my model in their system. Doesn't feel quite efficient to me, but this is the way it was done. And in the end, right, I make models for other people, for stakeholders, for model users, right? They are my business, my client I need to make a model for. And their job, among other things, is to actually understand the model impact. So if we are going to put this model into production, and it is version 2.0, right? What is then the impact compared to 1.0? How will it affect my business line? So we see different departments, and what I've learned over the last year, learning more about Azure, what it has to offer, I think we can use some of the technology, not per se to make one big team out of it, but to make our lives a little bit easier by having maybe a shared tool set or a shared resource set. We might be able to work more closely together. And I would like to highlight this a little bit in 5 steps. So I would like to start off to show a little bit how Synapse can be used as a data source. So this is item 1, right? So the historical team could maybe get data out of Synapse, being sort of a production system. Then I would like to show how Machine Learning Studio can be used to actually prep data and store data and make it available to others. Then how I, as a quant, can use Machine Learning Studio to make models. Then I would like to spend some time to actually show how we can implement models, both in maybe a new way, but also compatible with the old way. And I'll come back to that in a second, what I mean with this. And finally, I would like to show a little bit sort of a sneak preview how we can use maybe automated ML within Azure Machine Learning Studio to help business stakeholders understand better what the data and the model actually is doing. So before going into this, let's sort of in 3 minutes time take a pause and spend a couple of words on what actually Synapse and Machine Learning Studio is. Synapse is a product by Azure that has been in the works for a couple of years. It keeps evolving, and the picture you see on the left is something I just plucked from the internet, but I think it depicts quite well where I think Microsoft would like to go with it. It sort of ties in between Power BI, machine learning, other parts of the ecosystem. It sits sort of in the middle. And why is this? Well, it's both a data lake. It also offers a SQL data warehouse. It offers some analytics. You can do stuff with Spark in that as well. So it's sort of this partner that sits in the web of all the other resources. And today I would like to use a little bit of the SQL data warehouse to see how we can retrieve data, put a model into production in Synapse actually. And maybe in the next session, in another session, we can dive further in some of the native stuff that Synapse also has to offer. Well, on the other hand, we have Machine Learning Studio. Me being a data scientist, for me, this is my playground. I can use Jupyter notebooks in here. I can prep data, store data. I can do labeling jobs. I can control compute resources. There's even a no-code solution to make machine learning models. I can track my models. You can do a lot. As you may see, I am quite a fan, or I'm becoming quite a fan of it. And I hope by the end of my talk, you see some of the beauty of what this tool has to offer as well. And then without further ado, let's go back to this overview picture. I will swap back a little bit between this and the web browser where I have Synapse and Machine Learning Studio running to sort of guide you through my narrative. So let's see, do I need to swipe left or right? I need to swipe right. Let's have a look at Azure Synops. So let's see how it can be used as a data source. Well, if you open Azure Synops, here you see we have a playground at Schubert Village to play around in Azure. We have several things we can look at. So we have data, develop, integrate. So let's have a look at data. Because in data, you can see you can have, let's hope, linked workspaces. We have some data lake storage, and we have in workspaces, we can make a SQL database. And in this case, I've made a database for this Azure Thursday demo in which I have stored some data. So let's have a look at what this data precisely is. And we see here that this data, it's a relatively simple data set, but I hope it will speak to the imagination of everyone. It's about New York City taxi trips, and we can see whether this trip was tipped or not, what the fare amount was, the payment type, passenger count, trip distance in miles, I guess, because it's the US, trip time in seconds, and the time of the day when the driver picked up the passenger. And suppose that this is a system where data keeps being fed into on a daily basis. I myself actually did it from a CSV file in the Lake store. I loaded it into SQL, but imagine this is a system which is continuously data is being added. And I somehow would like to have a model that can predict for these features whether the taxi trip was tipped or not. And we can maybe imagine that with more passengers, people are maybe more likely to tip, or whether the distance was longer or the time of day truly matters. So let's see if we can figure this out and make a model and also put that model back into production. So this is my production system. This is where my data live. This is where my historical data team can source their data. And let's see how maybe in Machine Learning Studio, we can prep this data a little bit and make it readily available for consumption by others. So let's move over to Machine Learning Studio. And then when you open this, lots of things happening again on the left, several things going on. First thing I've done when I've opened Machine Learning Studio, I made some compute resource. So you see I have here a instance running. I also have one currently not running that actually has a GPU for when I do really intensive stuff for which I need lots of compute power, you can easily make new resources, etc. It's really quite handy. Then what I've done, I simply go to notebooks. I've done my homework, obviously, so I've prepped something. You get a bit of file structure. And let's see, I have here a Jupyter notebook. It's running on my compute instance. It runs in a certain environment. I've already loaded up my functions. And let's now simply connect to this workspace. So what it simply does, it will retrieve all of the information needed to communicate with who I am within Machine Learning Studio. And let's simply do something very basic. I'm going to retrieve the same data as I just shown in Synapse, and I will load it into a data frame. I've written a small function. It will connect via ODBC to the AT-demo1 database, and we can actually verify now that by running this command, indeed, it has loaded a data frame, 10,000 rows. We indeed get our columns back. Now I need to do some very small data transformation step. I need to change some data types, because later on we're going to use the Onyx package. Then I will explain why this really matters. But now that I have my data, maybe it's a good time to actually register my data set. So I use my workspace object. I have given my blob store name. I can connect to my data store, and I can register my data frame as a data set. And why would I do this? Well, I sometimes hear that data scientists, we are called scientists for a reason, we can be quite messy. I had instances where people asked me, hey, can you reproduce this model? What data set did you use? I was like, oh gosh, darn it, let me have a look. This will help me in these situations. By registering this data set, we see, right, it has registered the data set, successfully created and registered a new data set. We can go to Assets, Data Sets, and let's see if this New York City tip data set is there. And we see New York City tip data set, version 5, created 13th of January in literally a minute ago. We registered this data set. So apparently by doing this, I have made a new version. I can actually click on it. I can see that the version was created by me. I can go back to different versions. I can see how I need to consume this data. So it already generates some Python code that shows me how I can use this data. I can explore my data as well. And I can even see what models, if any, make use of this data set. So why do I get excited about this? Well, it takes only 2 lines of code to do something that is actually quite essential when you work at a bank, to make something auditable and traceable, to show evidence of how you created your model. I actually, together with colleagues, have written packages at banks to make sure we could register this, because the only thing we had was a Python running locally on a laptop. We would have been helped greatly by having this at our disposal. Well, another thing we could do, a data sciencey thing, we remove a little bit of outliers. Not going to go into detail, but there are some weird stuff in this data set, and let's split up this data set in a train and a test set. And once we've done this, what might also be a good thing to do is maybe let's also register this train and test set as well, right? So we can see it has created these data sets. We can verify here, indeed, right? Version 6 now, indeed, 13th of January, just seconds ago. And we have basically prepped our data set and created the data sets with which we can start do our analysis. So if we go back to our overview here, right, I can easily imagine that a historical data team can use Synapse to gather data, make data queryable, maybe even make some views available within a SQL database. And we can maybe use indeed Machine Learning Studio to do some further data prep and then register this data set and make it readily available for consumption. Well, some people might ask, well, right, is this using SQL not a bit old-fashioned? Why not use this data lake and just skip the whole SQL step? Well, I still find that there are good reasons for having SQL stick around. A columnar data store where you can use indices and foreign key constraints can be quite handy in a production setting to have some built-in guarantees that there are no duplicates in your records and stuff like that. And it will also come in handy when we're going to deploy our model later on. So having sort of done 1 and 2, let's see now if we can create a good model. So let's go back and let's start doing some data sciencey stuff. So just to show that this is not all PowerPoint and it is actually working, let's see if we can look at each of the different features in the data set, and let's have a look at this histogram. How is the data distributed? And we can see that maybe on average the fair amount was maybe $7, $8, $9, $10. We can also look at, hey, right, if we make bins out of this fair amount, do we see a difference in the fraction of tips received? So if you look at between 0 and maybe $4.75, we see that maybe a bit more than 50% was tipped. And we could maybe see a sort of trend that the more people spend, the more likely they are to tip. And we can do some analysis for all of these features. And in the end, maybe it's nice to have a table sort of summarizing by feature name how well they predict being tipped or not. And we see actually that payment type is a very good risk driver. And without knowing what payment type is, 1 and 2, I can imagine it must be either cash or by card. But that is why it's always nice to have a business stakeholder, somebody who knows about the business to talk to say, hey, does it make sense that I see this in my data? Well, then another built-in feature that I actually quite like is to help with the traceability, we can start an experiment. And we can use this experiment to log information what we're about to do. So let's give it a name. Let's simply start logging. We can log metrics with this experiment. We see up top that we've started the experiment. We can attach pictures to this experiment. Now I will show you in a second as well what kinds of overviews we can get back from this. Next up, I made a small pipeline including a logistic regression model. It's not the most fancy model, but I always try it at first because it's an easily explainable model. I actually can write it on a piece of paper. And remember, I didn't have the luxury to send the package to a production environment. I needed to write on a piece of paper how my model looked like. So we've done this as well, and let's also calculate what the model performance is. And we see overall, this is a good. It's almost 1. 1 is the highest score. It's a good model. I, as a data scientist, get excited about this. Now, then let's store this model. So we take this classifier object, and let's write it as a pickle file, as a package somewhere. And we can then use this pickle file, this model path, to actually also register our model. So remember, right, we registered our data sets. We can now also register our model. We give it some description of what it is. We can even attach the data sets that we used. We give it some tag as well. It is actually registered, and let me also end my experiment. And let's see, so we see in the top right as well, experiment ended. Let's see now what we get for free by having a couple of lines of code. What type of evidence is being gathered for us? Well, let's first go to models. We see New York City tip prediction version 9 created 13th of January, literally a minute ago. We can see some of the tags. It's created by me as an author. We can click on the model. Then we can see some other information. We can look at the versions. So you can see I've been playing around with this for roughly a week. We can actually also see the artifact, right? So the model object itself. We can maybe see if this is used in an endpoint. No, not yet. We can also see the data sets that we used to make this model. So to me, right, we already know how to version our code. We now have a way to version our data sets, and we have a way to version our models. And this is something that comes to me immediately to my mind when I hear about ML ops, right? We know about DevOps, way of working, and how to use versioning, and everything is code. We can register stuff, and we can do for making models using data. We want to also register our models and our data, and we have only a couple of lines, we can make use of the built-in functionality. So me being sometimes the messy scientist, this will help me create some structure for me. We also still have these experiments open. So let's have a look-see here. You can see Loft submitted minutes ago. Let's have a look. What do we then get here? Well, basically, we see a summary of all of the experiments performed by me, and we also get an overview of the metrics I provided. So we get a nice graph as well. So if I'm in the process of trying to tweak and find the best model, this can be my logbook of all the experiments I've done, and I can see, hey, right, I can see maybe trends in my model performance going up or down, and I can use this to help guide me further in the process of building better models. So I like it. I don't need to have any more a written notebook to keep track of my experiments and faults. It's built in. So coming back to this point. So me as a quant, not always not always caring about hygiene. I have quite some tools at my disposal to make my life and the life of the auditors, the life of my colleagues, much better. Let's now see if I can also do the same for my colleagues at IT Run. So can I send to them my handwritten document with my formulas, or can we also do something over there? Now I'm going to show you a couple of different options how we can approach this problem. One way we can do, what we can do is in a more modern way, is we can create an endpoint. I will not actually run this live because it will take roughly 10-15 minutes. But trust me that it works. We can look at the results and see if it is actually working. Because you can see on the 6th of January, I actually did this. And if you look at endpoints, so I may be forgetting to explain what we are doing here. We are taking the model we've just registered, and we're going to deploy it in a container instance. And it only takes 3 lines of code and then 15 minutes wait time. And then we can see in endpoints, hey, right, we have here indeed this endpoint created 6th of January by me, container instance. This still uses model version 3 actually. So it's an older model version. It again shows us how we can consume stuff. So I've used both AWS and Azure a little bit. And what I like about Azure is that it gives you pointers how you need to consume stuff. I find that in AWS, I'm always a little bit searching for how do I actually access it. But let's see if this endpoint actually works. So I can take this address, and now I need to swipe right where I have Postman open. I have this address here, and I can submit some data. So here we see the features for fare amount, payment type, passenger count. And if I hit send, I get something back. What do I get back here? I get 0.999 and 0.00009. Well, the first item is the probability that somebody will not tip. And the second one is that the customer will tip. So in this instance, it's very unlikely that the customer will tip. But if I change something, for example, I change payment type from 2 to 1, and I do it again, then it's almost a 95% chance that our passenger will tip. So this is actually, we can send data to this container instance and we get our model output back. So I would consider this to be already a model in production, but it's only for a single record instance. There's also an option, I'm not going to show it, but to do a batch job. What I would like you to and this, but I would like to focus on the third option. So I consider this deploying it via an endpoint as sort of the new option. Imagine that whenever a new data point enters our data lake or data warehouse, we can use this endpoint to score our record. But maybe we can also use something that is maybe a bit more familiar to people with an IT run who naively or natively know a lot more about SQL, for example, than I do. So let's see if we can make our model also available in Synapse and use it in SQL. For that, we're gonna convert our model object into a ONNX type model, and ONNX is the Open Neural Network Model Standard, if I think correctly on the top of my head. And it's basically a sort of standardized way of exchanging models between different systems. And what we're gonna do is we're gonna register this model as well. For this, we actually use ML Flow, and I will explain in a minute why this is important. But we need to register it in the appropriate way that Synapse can also use it, that the correct metadata is attached to our model. And we can see created version 6, and we can actually see in models, yeah, right, version 6, 13th of January, awesome, has created our model version. So let's see now what we can do with this in Synapse. So instead of me sending a piece of text with formulas to IT run, can we do something different as well? Here we see some tables, and the cool thing is, before showing this, let me quickly check. Yes, in Synapse, I've set up a linked service between my Azure Machine Learning Studio and Synapse itself. And once I've done that, I can do the following. I can right-click on a table, and I have now the option available, machine learning. Predict with a model. This sounds exciting. So let's see what happens if I press this. Then we see, hey, right, Azure Machine Learning, it will start to connect to my Azure Machine Learning service. And we can see here, yeah, model version 6, the one we just created. I can select it, and I automatically already get the mapping from my source columns in my table and how they map to my model input. This is actually why we use ML Flow to package our models, because we need to give this metadata to automatically fill in this type conversion. Otherwise, it will not work. So it's still a little bit in, as I will show later, it's still a bit in preview, but it works. If I now press continue, what do I need to do? Okay, store object in the database, save the prediction script as a stored procedure. Okay, let's do a stored procedure. Azure first day demo procedure. Load model in database table. Okay, so he will load the model. Let's load the model in the existing AML models table. What will happen now when I press deploy plus open script? Synapse will make a stored procedure, which we'll see in a minute. And it will retrieve the model from Machine Learning Studio, and it will sort of stage it in a SQL table, in particularly in this SQL table. So let's see what happens. Uploading the model, deploying the model. So far, so good. The query has been generated successfully. Okay, that looks promising. So what do we see actually here? And I'm not a SQL expert. I barely know that this is a common table expression. But what I actually like about it, in my mind, in sort of the old school world, in large corporate companies, SQL is abundant. There's a lot of built-up knowledge on how to use stored procedures, on how to build triggers, on how to schedule jobs. So having a stored procedure that takes our data from our table and then uses the tsql predict command to select the right model from our table and then sort of applies this model to this data. So now let's see what happens if I press execute. And so here we see our original columns, but now also our model prediction. So I can completely imagine that I am a data scientist. I'm the quant. I build models left and right. This is what I do. I register them, and the only thing now that I need to do is I need to communicate with my counterpart that is responsible for maintaining this production environment. Hey, I think I have a new model. Can we create a job that will populate the table every day because the BI reporting department would like to have their dashboards updated daily? Or I can maybe say, hey, right, I have a new model version. Can we update the job? And the only thing that we need to update is maybe the versioning in our stored procedure. And for me, this is where sort of old world meets new world. We can still have different roles and different responsibilities, but we can use new technology to make our life easier, to make the exchange of information easier, to make throughput times easier. That's why I got excited last year learning more about Azure and using these tools. So in my mind, I think we can very much still have these different teams, the historical data team, a modeling team, and maybe a more IT production focused team. But by having a shared tool set in the middle, we have a more easy way of talking to each other, of exchanging information, of models of data. In the end, having maybe a faster time to market for our ideas, or maybe helping our business stakeholder better. Speaking of which, I promised you to also help our business stakeholder, because I make a new model and he simply needs to swallow that there is some impact. Well, I can convince him that there is an impact or there's no impact, or that the data is indeed as it is, by also offering him something. So let's see if we can offer him something by using automated ML. And I know it's a little bit of a dirty word within data scientists, right? Having something without code or limited code, but it has its benefits. I will show you. So let's go back to Machine Learning Studio. Let's go to automated ML. Let automated ML train and find the best models without writing a single line of code. Well, that sounds like a big promise. Let's see if that is true. All right, so I selected create a new automated ML run, select a data set. Oh, nice. So I now see already the data sets that are available in my data store. That is nice. So let me select my train set. What's up next? Okay. Let's create a new experiment. Azure first day demo automated ML. That sounds good. Select target column. What is the target column? Okay. Oh yeah, what we want to try to predict. Yes, we want to try to predict the whether there was a tip or not. I need to select my compute instance. Let's select the thing that I'm running. Next, select a task. Okay. Classification to predict one of several categories in the target. Yes, no, blue, green. Yeah, this sounds right. Yes, no, we want to predict tipped, yes or no. So this also seems good to me. Validation type, auto sounds good to me. Test data set, yeah, I remember that we have a test data set. So let's also select this test data set. Cool. Finish. All right. This job is simply going on, and you might now wonder, hey Frank, but do you really expect a business stakeholder to also do this themselves, right? Well, the reason I'm showing you this is twofold. One, I would like to show you how easy it is without any code to do this. You can actually also execute this job by writing a couple of lines of code. But what I like most is what you get out of it. So let's have a look while this is running at the run that is already complete. What's happening here? We see lots of information again, some performance metrics, what data set is being used, created by me. But we get more. We get data guardrails, so it tells us something about whether we've done the validation split correctly, whether there was some class imbalance, something about missing features. Don't know precisely what it means, but it's all green, right? So it must be good. It's oh wow! So it basically what it does, right? It tries, in this case, more than 90 different types of models to find the best model. Well, me as a business stakeholder might not be interested in all the varieties. I simply want the best model, but I see something else that draws my attention. View explanation. That seems promising. So what do I get? Okay, so hey, I see aggregate feature importance. So I see somehow how each feature is contributing to my model. Okay, well, this already tells me something about my model. So I'm learning something about my model. I like it. Individual feature performance. Okay. Oh, I get fair amount. Let's see, probability. Can I do so? Oh, hey, select your access value. Okay, data set, fair amount. Let's do trip distance. Okay. Oh, this seems also nice. So I get also a way to interactively explore the data. So I can see, for example, trends and patterns. So in my mind, if I try to imagine, right, being a business stakeholder or a data expert, I have an empirical gut feeling of how my data should look like. I can explore it here. I can have a look here in the same tool set as that my quant counterpart is making my model in. I can directly ask him questions. We can have the same interface to talk to. Nice. I like it. So I've now sort of narrated this a little bit from the perspective of this business stakeholder, but actually I would use it myself as well. While I am playing with my data, trying to understand my data set better, why not have it run in the background, doing a brute force search of all the best models out there? Why not help yourself with a computer on your side, trying to find patterns in your data and trying to find the best model? It makes my life at least easier. So I'm nearing the end of my talk, and I hope to have given you guys a little bit of the flavor and the excitement that I have for these types of tools. And by having this sort of context from my previous career as a quant in a bank wearing the suit, that you can sort of see why it would have helped at least me and my colleagues immensely having these tools at our disposal. Well, it's not, if you are as excited as me, right? What to do next? Well, I would say just get started. I followed, amongst other things, this link with a tutorial on this using these SQL pools and this model scoring wizard. That was nice to follow. Some things that I learned is Machine Learning Studio is cost-wise, it's relatively cheap. It's also easy to control. You can put a schedule on whether to spin up and spin down compute instances. With Synapse, it's a little bit more tricky. The dedicated SQL pools can become a little bit expensive. And you need to manually pause your SQL pool to prevent you from making more cost. So I will do this after this talk. I will also pause my SQL pool. And I learned that the scoring wizard in Synapse is still in preview. And it may be a bit of a technical detail, but we are using some Python libraries, in this case sklearn. We converted the model coming out of it into ONNX, and then we must somehow make this ONNX model play nicely with Synapse. And at each interface, there are knobs to tune to make it work correctly, and it can be a little bit of a pain. So I learned this the hard way over the last few weeks. Don't let it deter you or keep you down, I would say. Happy hacking. And if you would like to know more, or if you would like to brainstorm about this latter part, about how to tie all these things together and make it work in Synapse as well, just reach out to me on LinkedIn. With that said, I would like to thank you all for your attention. I cannot see you, but I know you're out there. I see Roland coming back in. I know that Roland was there at least. Thank you, and Roel as well. And I will give up my screen.
Thank you so much. It was so great. You shared it with. I didn't feel dumb watching you present this very heavy stuff, because there's some very powerful things going on here, because you're now showing this it looks that easy that I think I could even do it. Well, I have experimented some with the older machine learning studio. The portal has enriched greatly, but it is a very nice session. It was very nice how you did it. I really loved it. And
Cool,
we have
glad you
some
like it.
questions.
Yeah. Shoot.
And the first one is from Bart from YouTube, and I think I can show it on the screen. And it is how can we publish the models and expose these APIs that we create through the Machine Learning Studio? How can we expose them to external parties? And how can we secure those? Do you have any take on that?
Yeah, it's a good question. It's something that we ourselves are also still a little bit exploring with, because at the moment of writing, we are deploying Synapse for one of our customers, and so now I wade into engineering territory. So I will start to feel dumb at the moment, Roland. But I know that we are having some struggles with trying to make it all VNet integrated and make it secure. So at the moment, I'm doing this in my Schubert Village playground. It's secure by our standards, but not production ready secure. This is actually something I still need to look into. So this API that I was showing you, I can give you the web link and you can use it as well, right? So you can fire at it at will.
Yeah.
I would not know honestly yet how I need to secure this, how I need to build an interface around this.
And thank you. We the engineers can help there, because
right, yeah.
A container instance, so we can secure that container instance like we would do any other container instance in Azure. So we can protect that there. I'm not sure how it is key wise. You probably need a key as well to invoke the API, but that is, of course, you can manage that, because that is a production scenario.
Yeah.
You will face probably. What I really loved was a Synapse integration you showed us. I had not seen that before, and it was so powerful to see how easy it was. And you explained it very well, that there is an entire generation almost of engineers that knows SQL from the back of their hand, and they don't know nothing about machine learning, and this is their entry point to just using those models with a syntax they already know. So there was
and I honestly believe that there is still a future out there for having a SQL data warehouse. I can imagine so many use cases and scenarios. So why force us to move away from something that seems old and cannot keep up with the latest tech and features out there? So I like that this is bridging the gap between old and new.
Yeah, very much. Thank you. In regard to throughput in Synapse, how many records can we score at once? Because the data warehouse can contain huge amounts of data. Is there some limits to that?
So what I showed at the moment, to give a bit of context, this was simply 10,000 records being scored, and I used the very smallest SQL pool that I could find.
Okay.
So and in my experience, and this is why I think it's still in preview, if you bring more complex models to production, somehow the compute in Synapse is not fully optimized to handle those more complex models. So going from a logistic regression to a random forest to some decision trees, some boosting or neural networks, you can see a steep increase in compute time.
Yeah.
in my gut feeling, it's not related to record size. It's or data size. It's more on the model complexity compute end of view.
So there's still an optimization.
Yes, but having
thing
said that,
happening.
I was pleasantly surprised by the speed of the logistic regression model, and it may be old-fashioned, but lots of banks, this is the backbone of the models within credit risk. So already within that setting, I can see many applications.
Very cool. I think I noted I written down my questions, and I shouldn't do that because I'm now looking down.
Can I do one in the
Yes,
meantime,
please.
Roland? So right there at the end, you showed that the system determined what the best fitting model was.
Yeah.
How? I mean, I don't understand any of this. So how does
Yeah.
that work? How does it have an opinion about 10
Yeah.
models and which one's best?
Yeah, so the funny thing is the machine is actually doing 70 or 80 repetitions of what I was showing as code in Python. So I need to tell to Python, or in this case to the machine, hey, this is the column you need to build a model for. Find me patterns that explain what you see in this column. Then I also say to him, right, all the other columns are basically your playground, your garden from which you can choose and try to match what you see in this column as maybe patterns in the other column as well. So for a human, it's easy. If you have only 2 columns, you simply plot them, X versus Y, and see, hey, right, I see this wavy pattern in it. This is how I should relate this one to this one. Our mind as a human cannot do this for more than 2, because then we need to start to think in multiple dimensions and it blows up. But a computer can easily do this. It can take many columns and tries to find patterns to explain what he sees in this single column. And he does this systematically. He tries this with method A, with method B, with option 1, with option 2. He brute forces it. So it may appear to be a smart computer, but he just tries a lot.
And he had a really easy time, right? This data set, because there was one feature, I think it was payment type, that was
that did extremely well. Yeah, so I also played around with this automated ML of a much more complicated data set. I took one from a competition, a Kaggle competition, and I basically within 1 hour I had the same score as the top scoring model on Kaggle. So, and that I find powerful, because then I can shift my focus from building models, doing the nitty-gritty sort of all of the writing code. I can then spend time on understanding the data, on understanding the impact of the model for the business. I can help explain my model to the business. And then I can do the part that I like as a data scientist as well. Yes, I get enjoyment of building models, but it's the connection with why I do it that gets me excited.
You get to do the science part in the data science, right?
Yeah, because it's then we get to talk about, hey, but I, as an expert, expect that this feature is very important. Why is it not in your model? And then you're like, yeah, you make a point. Let's look into this. And then we start iterating, right? That's where the experimentation comes from. And that's where it's nice, where we have an environment where we can log our experiments, our incremental process. And then somebody's like, okay, damn, there was an error in our production system. Our data is not good. Let's give you new data. Then we're like, okay, we need to register this. And now we have a place where we can register our new data set as well. So this whole iterative cycle, we get all of the tooling in place to focus on the thing that matters, the process, how to get to the best model.
Yeah, so cool. One last question, if you would permit it. Is there any A/B testing features going on there? Because I could expect you have multiple versions of the model, and maybe you just want to try them out in production because you have this data, your training set, your test set that is well, I hope it is representative of the production environment. Maybe you're getting really other results from production. Is there a way to have them both there out in the wild and compare them?
Yeah, I would say so. I haven't thought of using multiple model versions to do A/B testing, but I would say, right, you've seen me click the stored procedure and select a version. I can easily make another stored procedure of a different version and have it score 2 tables side by side and try to compare what's out there. Yeah, why not?
Very cool. Thank you.
Makes sense.
Well, thank you so much. I think we're out of questions and we're almost out of time, so we can have a small break. So, Frank, it was amazing. It was an amazing session. Thank you so much for being with us. And I hope we meet in person somewhere this year when we finally get to without these really weird COVID measures. So thank you so much.
Thank you for having me. I had fun, and we'll see each other again.
Excellent.
For sure.
Thank you.
All right.
Thanks.
Take care, guys. Bye-bye.
Same to you. Bye-bye. Well, I think we'll have a small break until 8 p.m.
Yep.
And then we'll kick off again. And we have some amazing content around Terraform. And Anna's already waiting here. But we're going to let you wait for 5 minutes for starting the session. So you have some time for a small bio break to get some coffee. And we'll see you again in 5 minutes.
And we're back.
And we're back. And we used to have this amazing Be Back Soon video that we kind of misplaced. So sorry about that.
Yeah, those were the awkward 3 seconds of us looking around at the end there. Yeah, so we had a couple of minutes to process all of that stuff. That went way over my head just in the previous hour. But now we're going into my territory, so I'm really excited. And I'd like to bring Anna onto the show.
Yeah, please.
Hi, Anna.
Hi, hello.
Hi, welcome.
Good evening.
Thank you for having me.
How are you?
I'm good, yeah, I'm good.
Cool. Well, we're good as well. So I was looking at your profile before the session, and one thing stuck out to me that I wanted to ask you. And I don't want to ruin your first slide, so let's hope I won't. But I saw a whole lot of sessions and things you were doing that were related to data topics, and then all of a sudden, your topic of today is going into Terraform. So I was wondering where the bridge between those two came from.
Yeah, so I started off as a software engineer. So essentially I did a lot of DevOps, a lot of infrastructure as code, and I am now a data engineering consultant. And part of my role, or a big part of my role, is I often get asked what's the best solution when it comes to DevOps, infrastructure as code, for the projects and with the clients that I work with. And so that's essentially where this has come from. So I've worked with Terraform before in a previous role when working as a software engineer. But then I've taken those skills into my current role and used it with clients as well when they're looking for a really good, robust, easy to learn solution when it comes to infrastructure as code.
Great.
Cool.
So I'm really excited about your session. If you would share your screen for us, then we're ready to go. Here we go. So I'll add you to the stream. And then the floor is yours.
Okay. So hi everyone. Thank you for attending my session on Terraform. Essentially, we are going to spend the next kind of 45 minutes, 50 minutes talking about Terraform, what it is, and some of the best practices when working with Terraform. So what are we going to do specifically? What is Terraform? So for those of you who haven't used Terraform before or haven't heard of it, we will go through the basics essentially of what Terraform is and why it is so popular. Working with Terraform Cloud's service providers, so CSPs, working with other Terraform providers, and then best practices, again, when working with Terraform, so when working in production. So who am I? Essentially, I am a Microsoft MVP. I've got a strong background in, as mentioned before, in software engineering, but I specialize essentially in data engineering. And so I've been in this current role that I'm in for the last 2 years. I work for a company called Advancing Analytics. And essentially, I now consult. So I go into companies and I help them with their data engineering problems as part of a team within the current company that I work for. I've got a Bachelor of Science in Multimedia Computing and a HND in Visual Communications. And as well as working with Microsoft, I've also worked with AWS, most recently Scala and Kafka as well. So contact and resources. At the top there, everything I'm going to show you, there is a Git repository. So you can go to that Git repository, there's a getting started guide, and you can play around with this yourselves. And that's just my LinkedIn handle and my Twitter handle as well. So specifically, what are we going to look at? We're going to run through the basics. We're going to look at working with a cloud provider, so in this instance, Azure. We're going to create a resource group, Postgres SQL database, a virtual machine, storage account, and essentially network. And then we're going to look at working with the Databricks provider. So this is an example of a provider that isn't a CSP. Essentially, it's one of the many, many providers that you get when you're working with Terraform. So we're going to look at creating, updating, deleting workspaces, clusters, and notebooks. and how to apply and enforce dependencies between resources, how to manage the Terraform state, and how to explore the Terraform deployment plan, and how to work with Terraform in Azure DevOps. So first things first, what exactly is Terraform? So Terraform is one of the most popular infrastructure as code tools. It's the third most popular cloud skill in demand for DevOps roles. So the first being AWS, then Azure, and then we've got Terraform. Terraform is the industry standard for infrastructure as code. So I've got that statement there. Whether it's true, jury's out, but it is essentially a very, very popular tool. So it is a very useful skill. But the question essentially is why, and we are going to go into that. So again, what is Terraform? It's a tool for building and changing and versioning infrastructure and safely and efficiently. Terraform can be managed existing and popular service providers as well as custom in-house solutions. So it's very flexible. Configuration files described in Terraform, the components needed essentially to run single applications or your entire data center. So Terraform has this concept of write, so you're writing your Terraform, and then you hit plan, so you're actually hitting plan and seeing what's going to happen, so what's going to be created, what's going to be deleted, what's going to be amended, and then this concept of apply, so you're actually applying those changes into your environment. And Terraform essentially fits into this DevOps model. So a lot of you have already seen this magical figure of 8 when it comes to DevOps. And we want to be coding, building, testing, releasing, deploying, operate, monitor, plan, and just going continuously around in that figure of 8. And essentially Terraform fits in that model when it comes to our infrastructure as code. And it's a really nice, easy tool to use. So talking about DevOps and infrastructure as code tools, some of the most common ones that you may already have heard of and used, we've got Azure DevOps there, Circle CI, Jenkins, Octopus Deploy, GitHub Actions. And on the infrastructure as code side, I'm sure lots of you have used ARM, and I'm sure lots of you have potentially been burned by ARM as well. When it gets complex, it can get quite difficult to work with. And then we've got Terraform there, and also Pulumi is a very popular one that's kind of up and coming. And finally, Azure Bicep, which is very, very new, but actually very similar syntax-wise to Terraform. So declarative versus imperative infrastructure as code. So before we dive deeper into Terraform, it's really important we understand the difference between these two and where Terraform fits in between these, and that helps us understand why Terraform is such a good tool when it comes to infrastructure as code. So declarative infrastructure as code is essentially what you see is what you get. It's explicit. It's more verbose, but zero chance of misconfiguration. It uses script languages like JSON, YAML, and XML. And essentially, the most common tools that we've mentioned before that you potentially already heard of would be ARM templates, Azure Bicep, CloudFormation, which is AWS, and Azure Blueprint. And there at the bottom there, we've also got Terraform, which essentially will work across cloud providers, whereas the others there are specific to certain cloud providers. Imperative infrastructure as code, you define what you want, and the rest of it is filled in. So it's implicit. It's less verbose, potential to end up with broken code, broken configuration, essentially. So it's less. It can be less robust depending on who's using it. But it does have more functionality than declarative, and it uses a variety of programming languages such as Python, Ruby, and JavaScript. So essentially, programmers love imperative infrastructure as code because they can use their programming language of choice. So examples there will be AWS Cloud Deployment Kit and Pulumi, which you mentioned before. So Terraform is declarative, but it is imperative as well. It's got little bits of imperative functionality. So we've got here that HCL-ish Terraform language supports loops, dynamic blocks, and locals, and also complex data structures, so maps and collections. So it isn't completely imperative, but it is kind of, it's dipping its toes into it. So it gives you that extra bit of functionality that other declarative infrastructure as code tools don't necessarily give you. So what are the benefits of Terraform? So state management, Terraform has this wonderful state management where you can have that safety net. It always tells you what's going to be changed, what's going to be deleted, what's going to be added. And it's really, really, really easy to work with. So that is that gating for you, that safety net. It is cross cloud. Now we're all Azure fans. I'm a Microsoft MVP, but we do almost all of us have to dip our toes into other cloud providers every now and then. So it is great to have this tool that is cross cloud and essentially AWS, GCP, as well as Azure. So it solves the issue of provisioning complex infrastructure, so often encountered with other infrastructure as code tools. And as mentioned before, with tools such as ARM, ARM is brilliant, it's great until it gets really complex, and then you start to hit issues, or it becomes less easy to understand or less easy for somebody else to pick up. So it has a simple syntax, essentially. It allows for easy modularity. Terraform lets you define infrastructure in config and code. So what are the Terraform core components? So I've talked a lot about it. I've done like a sales pitch as to why it's so good. What are the core components that you work with when you work with Terraform? It's literally split into two areas. You've got the Terraform CLI, and that's essentially the same as if you're working with like the Azure CLI. It is a CLI that you work with to execute your Terraform, your commands. And then you've got the Terraform language, and that is where you actually define your infrastructure as code. That is your blueprint. So the Terraform CLI, as I mentioned, it is basically a suite of commands that you can work with essentially in your terminal. So for example, over we've got Terraform init and Terraform Plan. So looking at it in a linear order, when you're working with Terraform, the first command you're going to execute is going to be the init, and that's the initialize. So you've got a fresh project, you hit initialize, and that initializes your project, which you will explore in more depth further down the line. You then can validate, so that will essentially validate your Terraform. So your infrastructure as code that you've written, it will validate it and make sure it's valid. You can then hit your plan that we talked about, and that will tell you what's going to change, what's going to be deleted. And then you can hit apply, so that actually performs those changes for you. So diving into the Terraform language, the syntax of Terraform configuration is called the HashiCorp configuration language, the HCL. And it's essentially meant to strike a balance between human readable and editable, as well as being machine friendly. So it's something that, again, anyone ideally could pick up and start working with, so more easily than other infrastructure as code tools. The main purpose of the Terraform language is declaring resources, which essentially represents the infrastructure objects. A Terraform configuration is a complete document in the Terraform language that tells Terraform how to manage and give collection of infrastructure. A configuration can consist of multiple files and directories, essentially. And finally, Terraform language consists of the following elements, and that is blocks, arguments, and expressions. And there's our first example of some actual Terraform where we're defining a resource. Where we're defining a resource, and there below you can see how it's described as a block, identifier, expression there. Okay, so now actually getting started. So actually looking at some real world Terraform and the CLI. First thing we want to do is actually talk about the structure. So you're going to write some Terraform. What structure should that be? Should you throw it all into one Terraform file, or should there be some sort of separation? So what we're looking at here is actually one of the standard ways of doing this. So we have a Terraform project at the top there, and then within that we have our core Terraform files, which we will explore, which is like the main output and the variables.tf. And then we have our modules, and each module essentially is a different type of resource or a different type of grouping that you've defined. And again, in there you have the same files there. So yeah, we've got our README and the main.tf, which is so it's the resource configuration for the infrastructure. The output essentially outputs the variables. The variables.tf, that is what it says on the tin. It stores your variables. And then we've got a .tf vars file, and that's essentially where we store all of our values that we want to pipe into our Terraform, into our CLI, which would normally be things like our secrets and our SQL connections and things like that. And then we've got locals, and they're just essentially local variables that we work with. And data.tf is essentially where you store components that you're not actually writing the Terraform for them, but you want to be able to grab them. So that could be a resource group, that could be a database, and essentially if you're creating data resources, that's where you can shove them. So in the repository that I shared with you, this one here, we will be looking at this essentially folder structure here. So we've got an Azure folder and a Databricks folder, and I've expanded it there, and we can see we've got Terraform, and then we've got a dev folder and a modules folder. So hopefully you can see that. This is essentially it here in Visual Studio Code. Now I'm assuming you're all familiar with Visual Studio Code. If not, it is essentially a really popular IDE when coding, working with other things such as databases and things like that. So essentially what we have here is exactly what I showed you in the screen share. We've got an Azure folder and a Databricks folder, and then we've got our dev folder here, which is our environment folder, our main.tf, provider.tf, which we essentially mentioned before. So talking about the environment folder, what exactly is that? I've skimmed over it so far. Essentially, the environment folder is exactly what it says on the tin. It is the environment that this particular instance is referring to. So this is our development environment. If this was a real world scenario, we would also have, say, a test folder and a production folder, and they would have the same, essentially the same files in there, like the main.tf, the provider.tf, the vars.tf. And that Terraform.tf, as I mentioned before, that is where we're storing all of our values that we want to pipe into our Terraform. So actually exploring these files and what they do. Again, you could just throw all of your Terraform into one file, but that isn't best practice, and I wouldn't advise doing that when you're actually working in production. And this is a big part of this talk, is actually talking about some of these standards that we adhere to make sure that we're doing these things right. So this provider.tf, essentially here we've got a little snippet from it. And what do we have? Well, we have some Terraform variables there. And at the top there, we're defining, I'm going to work with the Azure RM provider. So that's the Azure provider. That's the cloud instance that I'm interested in. So you're defining what cloud provider you're going to work with. And you need this, as this is one of your first steps when you're working with Terraform, is actually defining which providers you're interested in. And then at the bottom there, those variables, we're just piping in what subscription we're going to work with, what the client ID is, what the secret is. So that's the service principal, and your tenant ID within your Azure cloud instance. So the main.tf is your entry point. So essentially, whenever you hit a Terraform command, say Terraform Plan, a Terraform Apply, it will look for this file. So if you're running in the terminal, you make sure you're in that file folder structure in that location. You hit Terraform Plan, and it looks for this file, and it executes essentially your Terraform based on this. It's your entry point for all of your Terraform. And what we have here is, and we'll talk in more depth about state in a second. Essentially, this is referencing a external state file. So your state file can be local or it can be remote. And this is where we're actually referencing a remote state file. And that state file is stored in a Azure blob container, essentially. And then here we've got our Terraform modules. So I talked about we've got modules that break down into different components, so different areas. So essentially, we've got examples here of where we're breaking it down into resource groups and storage accounts. And that is defined in our main.tf. So we're saying I'm going to work with the resource group module and the storage account module. And then it's useful to note there, with Terraform, you can define your dependencies really easily. So we know that we're creating a resource group and then we want to put a storage account in it. We need to make sure that that resource group is created first, otherwise everything is going to blow up. And this is just the syntax to do that. We're just saying, I'm dependent on that resource group module. So you add that in there and Terraform will know to always create that resource group or update that resource group first. So variables, as previously mentioned, Terraform essentially has this concept of variables. But how you populate those variables, there's different ways. And so it's really important when you're working with Terraform, understanding the order of which this is actually prioritized. And I say this because I myself have been burnt, and I know people that have been burnt when it's looking for the values in the wrong place. So priority-wise, it will first look for environment variables, so environment variables on your system, or if you're in DevOps, on the agent. And then it will look for the TF-vars file that we saw before in the repository and in my screen grabs. And if it's present, it will work with that. And then it will look for tf-vars.json file if present. And then any auto.tf-vars files. And finally, and I do use this one, when you're running your commands in your terminal, you can just pipe those variables in there as well. And I quite often do this when working in DevOps, just so I can pipe in the secrets that I've grabbed from my key vault. So looking at the actual Terraform syntax itself, here's some examples here. We're defining our subscription ID, our client ID, and our client secret. And it's worth noting here, essentially, we've got marker sensitive here. What does that mean? Well, we don't want Terraform to output into our terminal at any point our secret. So we're just telling Terraform here, this is a sensitive piece of information. So don't ever output this when you're running essentially anything, which is obviously super important. So modules, what modules do we actually have? We have, as mentioned before, we are going to be creating a PostgreSQL database resource group and storage account and virtual machine there to work with our network. So we have a module per one of these. So essentially, we've broken this down per resource type, but that is open to interpretation as to what suits you best in your environment. So modules, the resource group module. So this is just a little snippet, and it's easiest to show you this in this slide. I don't want to do death by slides, but it's easier to show you the little snippets here, and then we'll dip back into the code again. So we've got a snippet here where we're defining a variable, a resource, and then we're outputting. So we're working with our prefix there. So that's just a little bit of sugar there that we can work with to build up the name of our resource that we're creating. And then we're outputting those values. And that is really key because we want to create this resource group, but then we need to work with it in modules further down the line. And working with output variables is the way that we can easily do this. And now we have our storage account module. So here we've got essentially using those data tags. So we talked about the data tags before. We've got an example there above this resource tag. So we're going away, grabbing that resource group, and that's being pulled in from that output variable that we looked at before. And then we're able to use that directly in our actual storage account here. So there's no magic strings here. There's no parsing in a variable with the name of the resource group. We're actually grabbing it as a data object and then populating that via that object. So there's less room for error there, especially when you're first working with Terraform, where you've got quite an elaborate array of Terraform, you've got a massive set of infrastructure, it does make your life easier and just catch errors a lot quicker for you, because you're actually working with an object and not any sort of magic string. So yeah, variable from the previous module there. And then our Postgres SQL module. So again, variable from the previous module, using our data resource group again, and then a password coming from a variable. So we've already covered variables and how they work. That's just an example where we're then parsing that through down to the Terraform so we can work with it securely. And then our module on the virtual network, a little bit more complex. So as you probably notice, this is slowly building up and getting bigger and bigger, but hopefully this is making sense. So we create a network, we create a subnet, and then we create a network interface. And essentially, this is building up your picture step by step. You're creating your network, and then your subnet references your network, and then your network interface references your subnet. So you've got a chain essentially of association there. So they always get created in the correct order. And then finally, our virtual machine here, we're then referencing our network interface. So hopefully you can see that how that all essentially chains together. So it looks like a lot of Terraform, but essentially when you break it down into different resources, it's pretty simple. So running the CLI commands. So we've gone through a load of actual Terraform itself, but now we want to, and that's our infrastructure defined, that's our blueprint, but now we want to actually run the CLI commands. We actually want to do the compute. We actually want to deploy this. Now, again, we're going to go through the concepts of all the core commands in a linear order. So you'd initially run the Terraform init to initialize, and that would go away and get all your providers and build that initial state file for you if it's needed. And then we've got validate, so that will validate that all your Terraform is correct. Then you hit plan to get your Terraform plan, and then we hit apply. So looking at that Terraform init. Now we are going to dip into the actual solution again. But initially, just looking here, this is where I've run a Terraform init. We've had a successful initialization, and it's happy, and it's told us it's gone away to get our Azure RM provider. If this didn't work, you'd have the red writing of doom. So if we step back into the code again. So what we've got here is I've got a terminal window open in Visual Studio Code, and if I run Terraform init, and I haven't covered how to install Terraform here, but essentially there's lots of information out there if you go onto the main Terraform documentation as to how to install it and start working with it. So if we're in Terraform init, exactly the same sort of output. We can see it's happy, it's gone away and got the provider we wanted. So it's looked at that providers.tf and said, okay, you want to work with Azure, so I'm going to go and get it for you, and it's happy. Admittedly, I did try this earlier because I don't trust the demigods. And so we already have what it creates for us, which is this Terraform folder, and that's where it stores all that info. So the provider that we've downloaded is in there. And it will also, because we are working locally, not remotely, when it comes to the state, it's also created as a terraform.tf state file. So moving on to Terraform validate, exactly what it says on the DIN example here. You run Terraform validate, it tells you it's successful, great, wonderful. What happens if that actually falls over? Well, I've got an example here where I've deliberately named a variable incorrectly. So we can see there we've got name equals var.resource_group_NAM, which should be name. And essentially because I've missed the E off the end, it throws as an error And this is a really easy kind of mistake to make when we're bashing out loads of Terraform. So it's really great to have that functionality in there that will actually validate our Terraform and not hit us in the face further down the line. So sorry about that. So if we were to run Terraform validate now, success, the configuration is valid, which is exactly what you want. I would have panicked if it would have said that that hadn't succeeded. And our Terraform plan we're now moving on to. So essentially our Terraform plan, as mentioned before, this tells us what is exactly going to happen when we are actually trying to deploy our infrastructure as code. So when we run Terraform plan, it will essentially say this is going to be created, this is going to be deleted, this is going to be updated. This already exists, which is what you don't want to see, but it happens. And essentially on this first slide here, I've run Terraform plan is trying to acquire the state lock, because the state does lock when someone is running Terraform commands, which is exactly what you want. You don't want two people doing changes to your infrastructure at the same time. And here, this is an example of where I've talked about piping those variables directly into your terminal rather than, say, work with a TFRs file. It's literally, I've performed the Terraform plan. It's been unable to find a value for that variable, that Postgres password. So it's prompting us to enter a value, and we've just entered my password in there. So here we've got an example of running the actual Terraform plan and an output, and it's telling us at the bottom there, because that may be a little bit confusing to us, it was telling us, it's saying 0 to add, 1 to change, 0 to destroy. So that's a really good example where the Terraform's already been run before, the infrastructure's already been created, but here we're making a small change. And above there, it's telling us I'm actually going to essentially make a change to the PostgreSQL database. So moving into our code base again, I'm going to run Terraform plan. As you can see here, this is a little bit more easy to read. Essentially, we can see a really, really big plan here. So this is greenfield. This hasn't been deployed before. So we've got lots of green X's because it's telling us, I'm going to create all of this stuff for you, which is quite a lot. And so right at the bottom, saying I've got 8 to add, 0 to change, 0 to destroy. So it's very greenfield. It's just this is the first attempt. It's going to go away and try and create all of this. But for some, that's not very easy to read. It's not necessarily readable for everybody, especially if there's a lot going on. There is tooling out there when you're working with your Terraform plan. And we've got an example here where we're able to upload a JSON file that we can create as part of the Terraform plan command. And essentially, we can work with that JSON file, upload it to tools such as this, and actually visualize that plan. So one second. Bear with me 1 second. Computer's not playing ball. Right. So hopefully you can see that okay. So we've got the Terraform visualization tool here, actually in the browser. And what we can do is we can actually click on these components. We can minimize them, expand them, and actually get more details as to what is actually going to happen if we were to then move on to our next step and do a Terraform apply. So yes, moving on to our Terraform apply. So here's our example output, as I've shown you before with the other commands. It's telling me essentially I've done a Terraform apply, and this is just saying apply is complete, resources added none, 1 change applied, 0 destroyed, and happy text because it's green. What happens if it's unhappy? Well, here's an example. It gives us basically, this is a really good example where we've tried to give it a password, like that password I showed you before, and it doesn't conform to the standards. And essentially that's been thrown back to us. And we've got a very quite readable, understandable message there, just saying the password does not meet policy requirements because it is too short. This is super useful when we're deploying lots of different infrastructure, that we can get these readable messages back and immediately understand what that problem actually is. So again, computer not playing ball, so yeah. So if we run the Terraform Apply here, this is going to think for a little while, and we can hit. It basically prompts you to say, do you actually want to do this? You hit yes. And it will go away and create all of that for you. And now just a little bit conscious of time. Essentially, trust me, it will go away and create it all for you and give you a nice green response afterwards that is happy. What we're interested in is the end results. And essentially, this green grab here shows us what it will create. This is what we'll get at the end of it. We'll get our resource group and we'll get all of our resources deployed in that linear order within your resource group. So when you get a massive amount of infrastructure, it's nice to be able to visualize it, right? It's like to be able to see how it all hangs together. And Terraform does have this graph command. Now, I appreciate this isn't very easy to read, and I'm not expecting you to be able to understand this from this instance. But trust me, if you run that command at the top there, that Terraform graph, you can output this file and then open it, and it gives you a diagram such as what we're seeing here, which essentially shows you how all of that infrastructure in your Terraform hangs together. So again, I'm going to skip over that just because I'm conscious of time, and then move on to that Terraform state file that we've been talking about. This is an example of the state file in a blob store. So this is in Azure in a blob store. And the advantage of this, the big advantage of this, is that everybody points to the same state file. So that locking that we talked about with the state, essentially, if you've got 2 devs working side by side, both working on the same infrastructure, both trying to deploy, you can make sure that they're not trying to do it at the same time and breaking each other's stuff. And so if they're both pointing to the same state file, one will lock it as if they're the first person to hit Terraform apply, and that will stop the other one from being able to start trying to deploy stuff at the same time. So it's a really good safety net there. Also on that note, Terraform will tell you if things already exist in your environment. So if you're trying to create something and somebody's already manually gone into Azure and created it, it will throw you that error back and tell you you're trying to create a resource that already exists. And in that instance, you can actually import that into your state file, which is super useful. So I haven't got enough time to cover that in this session, but that is a really useful feature. At the moment, it doesn't write the Terraform for you, but that is in the pipeline apparently, that would be a feature. But essentially, you can. This doesn't have to be for greenfield projects. This can be for existing projects that you're moving over to Terraform, and you can import all of that stuff into your state file and map it to your Terraform, and then run your checks to make sure everything is okay. Yep. So yeah, and you can explore it using the Terraform state command. So if we did Terraform state list, it would literally list everything in the state file for you in your command line, and you can start exploring it. So again, running a little bit short on time, so just skip over that. But this is all in the repository, as mentioned. So you're welcome to explore that and start playing around and message me if you've got any questions. But the next question is how to use in DevOps. So I showed you how to run these commands locally, and that's all nice, but we want to use this in our DevOps environment. We want to just kind of press a button or wait for it to be on a schedule and just let it do its thing. So using Terraform in DevOps, and particularly using it in Azure DevOps, is fairly easy. There essentially are some tooling on the marketplace that you can use to create yourself some Terraform tasks so you don't have to write the pure CLI commands. Some may find that easier, but others find it easier if there is actually a task they can work with. And what we're seeing here is where I've created a Terraform demo for CD pipeline and a Terraform demo CI pipeline. The difference purely being the CI pipeline just goes up to the plan stage, and the CD pipeline will actually do the apply. And with some clients with the CI pipeline, we have outputted the results of that to a Teams channel so they can react if there are differences in the plan that are unexpected. So that would run on a daily basis. And again, that would pick up if anyone's been messing around with the environment manually, so gone in and started creating and messing around with stuff, it would essentially pick up on that for you. So again, how to use in DevOps. So this is an example in a DevOps pipeline in Azure DevOps. So this is our YAML. So I am assuming that everyone's familiar with this. There's lots of documentation out there. If you're not familiar with YAML when working with Azure pipelines, we are essentially defining our job of apply. So that's a Terraform apply. Grabbing secrets from the key vault in a key vault task, and then we're able to pipe that into our Terraform task. Again, this is a marketplace task, so this is something I've grabbed off the marketplace, installed in my DevOps environment, and I'm able to create these Terraform tasks and then pipe in all of the variables that I'm interested in. So again, marketplace extension, some of you out there would be like, yeah, I'm okay with just creating a bash script and piping in all those variables manually. I'd rather use a bash script. It's more transparent perhaps. And this is just an example of just working with the vanilla Terraform CLI. So you don't have to use the marketplace tasks, but they are super useful. And then, yeah, we're working with our key vault secrets. Okay, and this is essentially our pipelines in the real world. So our CI pipeline, which is running successfully. It wasn't for me earlier. We can just see some success statuses there. And we've got it in different stages. So we've got our init, validate, and apply. And those are essentially our commands as we've gone over before. Our init, our validate, and then our apply there for the CD pipeline. Okay, so we have covered the Azure provider, and we've gone through some best standards, best practices, and we have talked about DevOps and working with Terraform and DevOps. What about the other providers out there? Well, not the cloud ones, but what about the other providers out there for different tooling? And a great example is the Databricks provider, because it is really popular. There's a lot of movement behind it. It's a great example, essentially, just of a provider that isn't a cloud provider that would enrich your environment. Even though you're working with Azure and that's all you're interested in, you'd still potentially, if you're working within data realms, work with providers such as this, a Databricks provider. So looking at some Terraform again, we are referencing our Azure provider, and then we can reference our Databricks provider there. And so they're going to work hand in hand. On Azure, we're going to create a resource group, and our Databricks provider, we're going to use it to create a Databricks instance. And again, this is all in the GitHub repo that I've provided. So we're going to create a workspace. So there's our resource group that we're creating with the Azure provider, and then we're creating a Databricks workspace using that resource group that we have created previously. And now we want to create our Databricks secret scope. And so exactly as you've seen before with our Azure provider, we're creating resources, we're telling it what resource type it's going to be, and then we can pipe in our variable values, exactly the same with any provider. So we're creating a secret scope, a path token, our secret to work with Databricks. And then we can create our cluster there. So quite a lot going on but still quite easy to kind of break down and understand what's going on. We're creating a cluster, we're defining what libraries we want to add in there. We're saying we're going to have Pi ODBC as a library, and essentially adding some tags. Oops, sorry. Sorry, my voice is going up. And then also we've got Azure attributes there. And then essentially we are working with Databricks notebooks. So we want to upload some notebooks, and essentially what we've got here is a base encoded path to where that Databricks notebook is going to be. And this is our end result. So essentially this is going to create us a Databricks instance in the resource group that we have defined. So two providers working hand in hand to achieve that infrastructure as code dream. And again, being conscious of time, I don't have time to demo it, but the code is there, so you're welcome to have a play around with it and reach out to me. So moving on to our summary. Essentially, Terraform is the third most popular DevOps tool. Providers aren't just restricted to CSPs. Terraform language is richer than alternatives. Managed lockable state allows infrastructure as code to be managed without conflicts or resources essentially disappearing. So essentially without things accidentally being deleted. It provides that gating, that security for you, especially if there's a lot of you working in the team or working towards deploying infrastructure as code, working with your current architecture. So the CLI commands are fairly easy to learn. So it's all out of the box. It's all part of the Terraform package. You learn Terraform init, you learn Terraform Plan, you learn Terraform Apply. And though there are lots of other commands out there, essentially, once you've learned those three and Terraform Validate, you can get going with Terraform and start playing around and understanding how it works and feeling comfortable with what it's doing and what it's deploying for you. It is easy to integrate with DevOps. It literally is a CLI. So as long as your DevOps environment has access to that CLI in its agent, you can run those commands in a vanilla way, or you can do it using, as I showed you, those out of the box tasks from the marketplace. So Terraform Plan provides valuable access and visualization of potential changes, and I can't enforce that enough of how useful that plan is and how easy it is to essentially explore it. Essentially, if you are interested in Terraform, and this is a shameless plug, I am doing a day workshop at SQLBits this year with my colleague. Essentially, it is data focused, but it will teach kind of the ground up, working with Terraform, the do's and don'ts, the gotchas, essentially what we've learned using it in the industry. Essentially, it is a workshop, it is paid for, but it is worth doing if you're interested in learning a little bit more about Terraform. So yes, thank you very much for listening to me. I hope you enjoyed it. Again, there's the code base. Download it, have a play around with it, and those are my my handles. So that is my LinkedIn handle and my Twitter handle there, and you're welcome to reach out to me.
Perfect. Thank you so much. You really demystified Terraform for me. It was a very, very nice session.
Thank you.
Yeah, thanks so much, Anna. It was really nice. I have a whole bunch of questions here. So if you're okay, I'll just fire away. First one is you showed the decision tree Terraform follows when it reads variables in. And I was wondering, where do the autovars files, where would those come from?
Which vars files? The TF vars?
There was like a star auto TF in there.
Yeah, I personally haven't worked with them, but they're on the list of the priority of the priority it takes, and they're right at the bottom. And so far, I've not had a reason to work with them. So I don't know the answer to that one, but I've worked with the rest of them. So I've worked with like the CLI when actually piping those variables in the TF-vars file, and I haven't had reason to work with the other.
Okay. I have another question from Esther here, and I can put it on the screen. So is the Terraform graph output based on the Terraform state file, or does it check directly with Azure ARM what was created for you?
So it's based on, it essentially is based on your Terraform. So it looks at the Terraform in your solution and it draws a graph for you.
You had another question, Roland, I think.
Well, yeah, this is a general wonder for me. Do you have any experience when Azure has new functionality? How long it takes that that functionality is available in Terraform for new types of resources?
I haven't had any experience of things being missing, but what I can say is with that Databricks provider, definitely use that over anything that's in the Azure provider for Databricks. There's a lot of movement around the Databricks provider, and there's a lot of new features being added all the time. So that's a really good example where you've got a separate provider which you can work with to make your infrastructure even more awesome. So.
Okay, cool. Thank you.
Yeah, another one. You said that when you use outputs from other resources, that it handles the ordering of the deployment for you. So then when we use depends on?
So you're using the outputs. Perhaps I worded that a little bit backwards. You have to use a depends on for it to be able to work with your previous module that it is dependent on, but you can pipe those variables in to the next module from the outputs of the first module. Does that make sense? So the depends on is still key, but it will grab the output variables from the previous module. So essentially, if you've defined a resource group and you want to grab the ID, because you've got the depends on, it's been created, and then you can grab that from the output. Does that make sense?
That makes sense. Thanks.
Yeah.
I think I have another one from Esther. Yeah, I think this is a nice one. Do you see a lot of usage of Terraform in hybrid infrastructure? So I think what she means is using Terraform and like one Terraform, what was it? Apply to deploy to two cloud environments at the same time.
I haven't used it to actually deploy to two cloud environments at the same time. I've used it in conjunction for different cloud environments. So you're working, say, with an S3 bucket in AWS that you're going to then pull a load of data into Data Factory and put into a data lake. I've worked with that sort of environment, and then you would have those separate bits of Terraform to work with that. So you're able to use the same infrastructure as code tool across the board, regardless of it being different cloud providers. But I haven't used it trying to work with two different CSPs at the same time. So it's an interesting question.
Yeah, I have one. This is a personal one. This is one I always struggle with a bit. So if you have two applications, for example, simple example is two web applications or two app services in Azure that need to use the same key vault, or something is shared between the two. Where does that shared part end up? Because in my mind, if both of them have that in their template, then they're going to be trying to deploy the same thing, and that doesn't make sense.
Yeah, so okay, so with a key vault, I potentially keep that in a separate solution because it is used in more than one resource, and then we'd work with those data tags to pull that key vault into those different Terraform solutions. So we'd make sure that our key vault is already created and updated accordingly, and then we'd have essentially, if we're talking about DevOps, our pipelines that then would work with any changes for those two different web apps that work with the same key vault, and they'll have those data tags. So if the key vault doesn't exist, it would, when it tries to execute that data tag, it's going to come back to you and say, this doesn't exist. I tried to find it and it's just not there in your environment. So that's a nice, easy error that you can work with straight away. Whereas if you're working with magic strings, it's not necessarily going to be the easiest to debug, or it's not going to be as easy, because you'd have to then manually go away and say, well, actually, does this exist? Why isn't it working? And so, yeah, working with the data tags so you've got the objects is the way forward, I think, with that.
Okay, thanks. I'll use that tomorrow.
That makes a lot of sense. Yeah, thank you.
Yeah, so one more from Esther, because she went all out in the chat. So here we go. What's your experience?
Yeah, we did that already.
Oh, that's the wrong one. Sorry. This one. So I'm trying to parse it myself quickly. So if you use templates for hybrid environments, would you have to have provider-specific settings?
So you can get a little bit mixed up with namespacing. So with the Databricks versus the Azure had a Databricks namespace, and that was a little bit fiddly. And my colleague had to find a workaround for that, because trying to work with them hand in hand could get a little bit tricky. You needed to make sure the namespacing wasn't getting mixed up. So you can hit little gotchas like that. But personally, it's only been kind of minor hiccups. So I've not hit anything that's been a showstopper yet.
Okay, well, that was all the questions I had and all the other people in the chat had. So I want to thank you so much for giving us this session, because it really cleared up a lot of what you said, Roland. It demystified.
Demystified, yeah. It really clarified some bits I was not sure on for Terraform, because I've used ARM templates almost too much, and Bicep. I love Bicep, but I have not done that much with Terraform. So there were some missing bits in the Terraform ecosystem, but you clarified it very well. So thank you so much for being with us and presenting such a wonderful session.
No problem. Thank you for having me.
Thank you. And I think that wraps up our first edition of 2022. Right, Raoul? This was it.
We did it.
No more questions. We did it. We aced it. But because of the amazing content we had from Frank and from Anna, it was two very nice sessions to start off the year with. We of course have many editions planned this year. The next one being the February edition. So it will be February 3rd, because this is the second Thursday of the month, but that is the exception to the rule, because in the first week of the year, well, nothing happened, right? So everyone is enjoying their holidays. But next February, it will be the first Thursday of the month as usual. So that will be the 3rd of February. And we will announce it shortly in probably the next week or two. So if you have any content or any sessions you would like to present at one of our Azure Thursday events, please feel free to reach out to us or fill in the call for papers or call for sessions that is on the Azure Thursday website. So please check that out if you have anything to share. And if you're not really sure on your presenting skills or whatever, we're not always experienced as Frank and Anna, but that's okay, and we can help you there as well. So please reach out to us, and we can plan a session for you. It could also be a lightning talk for only 10 minutes, but just reach out and we'll make it work. So thank you very much, Roel, for hosting today. it was a great experience. It was our first time together.
Yeah.
I think this was our first Azure First Day, and I think it was a very nice addition. So thank you all for being here, and see you on the next one.